Okay, Saxon 4 Math students, we are ready for lesson 78. It's going to be all about triangles today. We're going to learn how to classify triangles. That's put them into groups based on their attributes. Before we get started, let's take a look at some triangle types. One way to look at triangles is to categorize them based on their largest angle, okay? So if we look at the largest angle of this triangle right here, it is obtuse, isn't it? We've talked about angles, about how obtuse means greater than 90 degrees, and clearly this is greater than a right angle. So we could call it an obtuse triangle, okay? Now let's look at the greatest the greatest angle in this triangle. And you can see that it's a 90-degree perfect little square, fits right in the corner. So it's a right triangle. It's not only a right angle, it's a right triangle. Okay? But if we look at the largest angle of this triangle, it's still acute. It's smaller than 90 degrees. Okay? And all of the angles are. So this would be an acute triangle. Now, another way to categorize triangles is to look at the length of their sides. Okay, and if all of the sides are equal, then it's called an equilateral triangle. Okay, if two sides are equal, and you can see that these two sides are the same, but the base is a little bit smaller. Two sides equal, that's isosceles, which would be a fabulous spelling bee word for you folks who love to spell really hard words, isosceles. I still have to look that one up myself. And then if each side would measure differently, then that's called a scalene triangle. Okay, all the sides are different, so they can all be equal, two can be equal, or they can all be different. Okay, now we're ready to look at some of these examples. Example 1, draw a triangle that is both a right triangle and an isosceles triangle. And remember, isosceles means that two sides are equal. So let's give that a shot here. And first of all, I'm going to use my ruler, and I'm going to use it to draw get two sides that are the same. Okay, so let's go with 1 inch sides here. It's very hard to get them exactly right. Okay, now I'm going to rotate my ruler here, and I'm also going to draw this side at 1 inch. What's handy about my ruler is that when it rotates and locks in place, I know I have a right triangle as well. So let me move it out of the way now. Okay, and you can see right here that we've got a perfect little angle and that two sides are the same. So now I just need to use my ruler to connect these sides, and I have to rotate it to where it's just right. And that may be hard to do. Let's see. Okay. And now if I measure this side, if I take a look at it, I didn't mean to flip it. Okay. Need to make sure I'm still on inches. And when we measure this, you can see that it is greater than 1 inch, okay? So two sides are the same, isosceles. And I'm going to double check. I think it's SC. Yeah, ISOSC. Two sides equal. And they did it the same way. They measured their sides, made it a 90-degree angle, and then connected those sides. By the way, the side that is opposite of a right triangle, a right angle, excuse me, is called the hypotenuse. And I think I can spell that for you. So this side right here, let me highlight it. This side right here, it's called the hypotenuse. to double check it. Forgive me if it's not. Okay. And there's a really cool theorem called the Pythagorean theorem that says that a squared plus b squared equals c squared, and it truly does. If we made squares the correct size, then what would fill inside c squared would uh, be able to fill both of these squares as well. And I have a really cool video to show you that, to show you a little bit later. But the hypotenuse is always side C, always. The side that is opposite of that right angle. And it doesn't matter if this side is A and this side is B, or if this side is B and this side is A. What all that matters for the Pythagorean theorem is that the hypotenuse, the one opposite of the right angle, is C. And it's totally cool. Let's look at some lesson practice. Think about this one. Can a right triangle have two right angles? Why or why not? So let's look at this right angle that we made. If I made another one, my shape would have to be a rectangle, wouldn't it? It could not be a triangle. And here you have it. Let's look at B. What is the name for a triangle that has at least two sides equal in length? Isosceles. And C, use a color tile to model a translation, reflection, and rotation. And we had a lesson on this a few days ago, and we know that a translation is the same as a slide. A reflection is like looking in the mirror, sometimes called a flip, and a rotation is sometimes called a turn. So we will play with some pattern blocks. Please remind me, and I will let you do that. It'll be a lot of fun. We need to go back now, and you need to check lesson 77. So hit pause as you check 1 through 9. Hit pause as you check 10 through 27. And hit pause as you check 28 through 30 and the early finisher if you did that. Okay, now we're going to go on to some mental math. We'll save the facts for the end. Okay, number sense, 35 times 100. Well, we just look at 35 times 1 and tack on 2 zeros, 3,500. Counting by fives from 5, every number Ramon says ends in 0 or 5. If he counts by fives from 8, then every number he says ends in which digit? So if we start at 5 and add 8, we know we get 13. And then from 13, if we add 5, we get 18. So if we kept on, we would see this pattern of ending in either a 3 or a 5. Okay, 50% of $31. That means half of 31. Well, I have memorized that half of 30 is 15, but now I gotta look at this other dollar, and half of a dollar is 50 cents. So $15.50 is half of $31. Measurement. Jenna jogged 3 kilometers or kilometers. Tomatoes, tomatoes, however you'd like to say that. How many meters is that? Well, remember that kilo means 1,000. So 3 kilometers would be 3,000 meters. Money. The box of cereal cost $4.36. Tiana paid with a $5 bill. How much change should she receive? Let's work mentally with the change first. From 36 to 40 would be 4 cents. And from 40 all the way to the $5 mark would be 60. So add that together and you've got 64 cents. Rodrigo's school day lasts 7 hours. If Rodrigo attends school Monday through Friday, how many hours is he at school each week? So Monday through Friday is 5 days times 7 hours, 35 hours. Each CD costs $11.97. Estimate the cost of 4 CDs. And we would round this off to $12 and then say 4 times 12 is about $48. Now I think on our upcoming test, the problem might look a little bit more like each CD costs $11.97. what is the exact cost, and then how do you know your answer is reasonable? And if it asks you that, then do it using rounding and say, well, my rounded answer is very close to my exact answer, and therefore it's reasonable. I know it makes sense if both of those are very close. Okay, calculation. Here we go. 50% of 88, that's half of 88. 44 plus 11, 55, divided by 11, 5. Okay, problem solving. Vanessa is mailing an envelope that weighs 6 ounces. The postage rates are 39 cents for the first ounce and 24 cents for each additional ounce. If Vanessa pays the postal clerk $2 for postage, how much money should she get back? So this is a two-part problem. First, we have to figure out how much it's going to cost, and then what her change will be. And I like to make a table for this. We're going to go all the way up to 6 ounces. I have to remember 39 cents for the first and 24 for everyone after. So ounces, 1, 2, 3, 4, 5, 6. And we know it's, I think, let me double check, 39 to 24. Okay. 39 cents for the first one. Now I have to add 24, and let's see what my total would be for the second, for up to 2 ounces. Okay, 13. I'm up to 63 cents by the second ounce. Okay, now let's add on 24 more cents. So after the third ounce, we're up to 87 cents. Okay, plus 24. Okay, now I'm at $1.11 for up to a 4-ounce package, plus 24 cents. Now I'm up to $1.35, but we still have 1 more ounce to go. So we've got $1.59 is what her 6-ounce package will cost to mail, but she pays with a $2 bill. So now I need to find the difference between the $2 and $1.59. Finding the difference always means subtract. My zero needs some help here, and I'm going to combine a couple of steps and borrow from the 20 and make it a 19. It's a little faster. 10 minus 9 is 1. 9 minus 5 is 4. 1 minus 1 is 0. So her change should be 41 cents. Okay, now let's do some mental math. Your job is to see if you can go as fast as I can. Are you beating me? Your brain should be faster than my pen. And there you have it. I hope you were faster than I. And we are finished.